In this video, we're going to take a look at problem 3.3 and how we divide positive and negative integers. As you watch the video, I would encourage you to just jot down any notes that you think are helpful in your spiral. Let's dive in. So let's talk about what we know so far. When we subtract negative integers from positive integers, remember we really need to look at the absolute value of each integer, right? We're looking at how far away that number is from 0. And the difference of two negative numbers can sometimes be negative. Not always. If the second number has a smaller absolute value than the first, then the difference will be negative. So we have -5 minus -2 equals -3. Let's talk about what we know when we multiply positive and negative numbers. We multiply the absolute value of each factor to find the product. Remember, the product is going to be the answer to your multiplication problem. If the signs of the two factors, not products, are the same, then the product will be positive. So if you have a positive times a positive, then your product, your answer will be positive. If a negative times a negative, your product will be positive. Now, if the signs of the two factors are different, meaning one is positive and one is negative, the product will be negative. So we also know that there's this relationship between addition and subtraction. Think fact families. There's also a relationship between multiplication and division, and these are things that we've looked at when we were looking at fractions, and we looked at models, and we looked at groups of. There's this reciprocal relationship between multiplication and division. The same applies with positive and negative numbers. So let's think about what we know so far. We have 36 divided by 4 equals 9. Well, we can quickly write out the fact family for this. So we can say, well, if that's true, then 36 divided by 9 equals 4. And 4 times 9 equals 36. And 9 times 4 equals 36. Remember, the magic number here is 4, right? There's going to be 4 number sentences for a fact family, 2 multiplication and 2 division. So if this is true, then if this number sentence is true, then the rest is also true. So we have another example here. We have 6 times -3 equals -18, and -3 times 6 equals 18. And on the right side, I gave you another problem, 6 times -13 equals 78. I would encourage you to go back and actually fill this out. So you might be thinking, well, why is this important? Well, it's important because you might be given a problem like n divided by 6 equals -13. In order to solve this problem, we can actually go back to this fact family here. Because if this is true, then we can also say that -78 divided by -13 equals 6. And then if we have n, some number divided by 6 equals -13, this actually is related to here. And we can see now that n equals -78. There's another fundamental property here that is important to note. Notice that you have right here, you have a negative divided by a negative, and you get a positive quotient. And then in the second one, you have a negative divided by a positive, and you get a negative quotient. So there's also a relationship between the signs in multiplication and division problems, and then the signs of your two factors and what they're going to do either to your product or your quotient. All right, let's go ahead and get this erased and keep moving on. So can 36 divided by 0 equal a rational number? Meaning, if we were to have this, 36 divided by 0 equals, let's call it n, okay? Some might say, oh, well, it's going to equal 0. So now let's actually go and think about fact families again and use fact families to prove whether or not this is true. Can n be some sort of rational number? So let's just rewrite this, 36 divided by 0 equals n. Then that would mean that 36 divided by n equals 0. So be thinking about that. Can I divide 36 by a number to get 0? And the also same true would be 0 times n would equal 36. So let's stop there for a second. Can I multiply n? Can I multiply 0 by a number to get 36? And that answer is no. So this here, 36 divided by 0 equals n, does not yield or give a rational number. So we also know that 0 is the additive identity for addition, meaning, right, when we say this, when 0 is added to any rational number, the value does not change. 1 plus 0 equals 1. So now let's think, is there a multiplicative identity where I can times a by any number and get itself? Are you thinking of it? Is a number coming to mind? A number should be coming to mind, and that number should be 1. So we can say that 1 is the multiplicative identity, meaning any factor, so any factor, whether it's 300 or if it's negative 3, multiplied by 1, I get the same number. And that is it. I encourage you to go back and check out your notes and use your notes for the remainder of your problems for today's work.